Today, a momentous occasion. Waptec has actually proven that a smart meter can technically put out more electromagnetic field by some measurement, by 5,000 to 1, more than a 13 kilovolt power line at 60 cycles per second carrying millions of watts. How? By deliberately looking up the most extreme case possible. The measured smart meter electromagnetic field output at 2.4 gigahertz, or that's under 1 watt of energy, and the 902 megahertz maximum 1 watt range. It's watt, and it's turned off and on all the time, but that's the actual maximum output, or more accurately the maximum amount of energy you can put into it. It doesn't really put out that much wattage, but anyway, is indeed at 2 milliwatts per square centimeter. 2 milliwatts at peak, worst case scenario. Destructive testing of a meter, someone got it up to 2 milliwatts, technically 8, but I'm using the self-destruct mode. It's obviously not 2 milliwatts per square meter, or per square centimeter. But it is technically 5,000 times higher of an intensity level than a power line in China. Yes, it is, in China. Because it's at 4,000 nanowatts per square meter at 13,000 volts, because it's at 60 cycles per second, 6 microteslas, and low frequencies don't produce the same milliwatts per square centimeter that a radio transmitter does, because that's the point. We're not using power lines to send and receive dits and das. We're using radio frequency signals for the same reason that light travels through space for billions and billions of light years, but the power lines don't. But yeah, it does. Obviously, it would be more intense if you measure it in nanowatts or milliwatts per square centimeter, because it's at 6 microteslas for a power line. If you touch a smart meter, it won't literally blow you apart and cook you like a damn hot dog. So anyway, here we go. RF output 2 feet from a smart meter. We'll call that 1 time, since it's literally 1 watt. And we'll just call it a ratio here at 2 feet. If you get 2 feet away from a laptop computer, it's that intensity or twice as much from the computer itself. It's not the Wi-Fi. If you're inside of a Wi-Fi coffee shop, like I am every damn day, they're twice as much or 1 time as much. So literally your laptop with Wi-Fi is probably more intense. They're not really specifying which way, but I'm okay with that. An active cell phone pressed to your head when it's idle, not receiving a signal and not doing a burst of data, is 3 times as intense as a smart meter. It can go up to 1,000 times more during pulse mode, like if you're trying to call from a really crappy connection, but that's max rating. Does that mean it puts out 1,000 watts? No, it doesn't have a 1,000 watt output. All of these things are rated by the wattage input maximum. But let's go on. A walkie-talkie is 4,000 times more intense than a smart meter, and 4 times as intense than a cell phone, because it uses lower frequencies. And any of you ever played with a walkie-talkie? Or it'll be about 55 times more intense. That's 6 watt limit. If you didn't know that, walkie-talkies are limited to 6 watts. You see the wattage limit and the effective real output, the efficiency on all of these is really shit. The signal isn't really even a watt. Active microwave oven, and you're 2 feet away from the door, excuse me, is 550 times more intense during peak than a smart meter. And this is required to be tested under FCC Part 15 rules to determine what the hell they put out and what the upper limit is on the transmitter. A transmitter can be rated for 5 watts and put out very, very little wattage. The efficiency doesn't have to be the same. It's not 100% efficient output. Some frequencies you can use, you really do get close to 100% efficiency. So you can use lower power consumption transmitters. It's a 1 watt peak transmitter. That's usually the consumption. It can also be the output. It depends on what they're measuring. So you actually measure the actual energy output. And remember, a power line carrying a gigawatt of energy puts off literally 5,000 times less energy than a smart meter. So this person says, smart meters radiate 5,000 times more EMF than a 13,000 volt transmission line. Because he found that ratio to occur. Yes, it's also at a frequency that is, okay, we're at 900 megahertz divided by 60 cycles per second. Do you know how the power converting curve works for when you multiply frequencies? Are you an ignorant twat posting under my channel? These things are extremely dangerous. No, they're not. You're claiming they're extremely dangerous by comparing something that's normally measured in microteslas, because that's more useful, to something that's measured in milliwatts, thousands of watts per centimeter. Remember, this is putting out 2,000ths of a watt per centimeter squared at a distance tested. Okay, it is putting out, let's say, a watt of energy in every direction, just like the power line, right? Radiating? Radiation is a scary word. It radiates. That means it spreads out, gets thinner. The square cubed quadruple backflip rule. Anyway, let's go on. Next one. Check out the geolocation. Oral Badak Passing Central Indonesia. That's where the SOS danger evacuate cautious not human SOS and then the string of code was, because someone made up some silly meme and it got some traction. Check out the geolocation. That's not a geolocation, it's a random number put in. When I looked it up, I found all sorts of things, including patent numbers and telephone numbers. It's not a geolocation because it's missing pieces of it to make it a degrees and minutes and seconds. It's not a measurement of the location. And also it didn't match up with anywhere in Indonesia. The actual numbers, if you put them in conventional format, show a totally different location. It's not where mh370 landed or crashed. But thanks for posting. Next one. Do you understand the concept behind quantum computing? Yes, I do. There aren't any quantum computers. Full stop. People lie about this a lot, because you can make money if you bring it up. Well, it involves quantum technology. Yes, a random number generator based on quantum theory would be useful because it would be truly random. That doesn't mean it speeds up the computer. How this achievement might alter human civilization. We would have better random number generators. That is actually very, very important for some things. But the computers involved are simply liquid helium-cooled computers. That's all. So there you are. So I'll include quantum computing. It's not an achievement yet. We don't have a computer that runs on quantum physics for any processing or data storage, because it simply does not. We have something like that, but then again, a Zener diode, well, not a Zener diode, a tunnel diode runs on quantum. It actually exploits a quantum physical effect. It does. Quantum tunneling. It literally does. Or electron tunneling. Normally that's a problem. So, parlez-vous to vous, we will review. Quantum computing is a boondoggle currently and is not actually being used, even though people muff the subject so that they can keep talking about it and make it a news story. I really freaking hate this. Geolocation data in a message that somebody made up out of their butt, pointing to somewhere that is not in Indonesia, is not in Indonesia. And it is actually a sequence of numbers for some other purpose, probably randomly picked. And the idea that smart meters radiate 5,000 times more EMF than a 13,000 volt transmission line is ignoring the fact that the transmission line at 60 cycles per second is working at literally 15 million times lower frequency. So I guess it would radiate less energy at a distance because it's really not radio signal. But hey, if it makes you feel better, look at links below me to Forbid TV proving you wrong.